Forget what you think you know about ancient medicine, because in 1980, inside a university laboratory in Atlanta, a scientist named George Armelagos pressed an ultraviolet light against a 2,000-year-old bone pulled from the Nubian desert, and it glowed, not faintly, not ambiguously, a bright, unmistakable fluorescent yellow. Now you might be thinking that sounds like a contamination problem, a lab error, an artifact of the burial environment. That is exactly what the scientific community assumed at first, until they ran the chemistry. That yellow glow was tetracycline, a broad-spectrum antibiotic, chemically bonded to the mineral structure of human bone, in remains dating back nearly 2,000 years. And here is the problem with that. Tetracycline was not supposed to exist until 1948. It requires complex biosynthesis by a specific soil bacterium. It was considered a triumph of 20th century pharmaceutical science, but it was already inside ancient bones. So let me ask you a straightforward question. What if everything the history books told you about ancient medicine, the idea that it was all prayers, animal sacrifices, and superstition, what if that narrative was simply wrong? Stay with me, because the data we are about to break down does not just challenge assumptions, it dismantles them entirely. Let me show you exactly what the chemistry revealed. The bones studied by George Armelagos and his team came from populations living in ancient Nubia, the region south of Egypt proper, deeply embedded in Egypt's agricultural and trade systems. These people were drinking Egyptian-style fermented grain beer and living under the same medical traditions as the Nile Valley civilization beside them. The first thing the lab confirmed was this: the tetracycline was not surface contamination. Tetracycline has a very specific chemical behavior. When it enters the human body, it binds permanently to hydroxyapatite, the calcium mineral that makes up human bone. That bond does not come from soil contact. It does not come from the burial environment. It only happens one way: sustained, repeated consumption over time. The second confirmation came in 2010. Mark Nelson at Paratech Pharmaceuticals published a detailed follow-up analysis in the American Journal of Physical Anthropology. His team measured the tetracycline concentrations precisely. The levels were not trace amounts. They were therapeutic doses, concentrations comparable to what a modern physician would consider a clinically effective antibiotic course. But here is the piece of evidence that changes this from interesting science into something far more important. Children's bones showed higher tetracycline concentrations than adult bones. Stop and think about that for a moment. If these populations were accidentally consuming tetracycline through contaminated food or water, the distribution across age groups would be random, uniform, unrelated to age, but it was not random. It was age-targeted. Children received the highest doses. Adults received lower doses. That is not the pattern of accidental exposure. That is the pattern of deliberate medical treatment. The same pattern a physician follows today when calculating weight-adjusted antibiotic doses for a sick child. The ancient Egyptians were not stumbling into antibiotics. They were prescribing them. Now here is the question that follows naturally from all of this. Where did the tetracycline come from? And the answer, once you see it, is almost embarrassingly obvious in hindsight. The ancient Egyptians called their beer heket. It was thick, dense, and nutritious, closer to a liquid grain porridge than the clear beer we know today. It was brewed from emmer wheat and barley, fermented in ceramic vessels at low temperatures, and consumed by virtually everyone in Egyptian society: workers, priests, children, royalty. Heket was not a luxury. It was a staple, a daily source of calories and hydration in a desert civilization where the water supply was not always reliable. And here is where the biology becomes extraordinary. Streptomyces, the bacterium that produces tetracycline, thrives in exactly two environments: warm, nitrogen-rich soil and fermented grain. The Nile silt that coated Egyptian grain storage facilities was extraordinarily rich in Streptomyces colonies. The slow, low-temperature fermentation conditions of Heket brewing, warm ceramic vessels, prolonged moisture exposure, stored emmer wheat, were almost perfectly calibrated to encourage Streptomyces growth and drive tetracycline production as a metabolic byproduct. George Armelagos spent years cross-referencing this fermentation data against the bone residue analysis. His conclusion was careful, but unmistakable. The conditions under which Egyptian beer was brewed were not accidentally favorable to tetracycline production. They were consistently, precisely, reproducibly favorable, across breweries separated by centuries and hundreds of miles. That kind of consistency does not emerge from accident. That is the result of observation, testing, refinement passed from generation to generation, and this is where the scale of what the Egyptians built becomes genuinely staggering. In the 1990s, archaeologists from the Oriental Institute excavated an ancient brewery at Abydos dating to approximately 3400 BCE. This was not a small operation. The facility contained ceramic fermentation vats large enough to produce over 300 gallons of beer in a single batch. 6 brewery units have been identified at the site alone. Estimates suggest the complex could process thousands of liters per production cycle. This is pharmaceutical-grade infrastructure, built 6,000 years before the concept of a pharmaceutical industry existed. The Ebers Papyrus, dated to approximately 1550 BCE, contains over 900 documented medical prescriptions. Many of them call specifically for fermented grain preparations, applied directly to infected wounds and ingested for internal infections. Archaeologists once classified those prescriptions as ritual or folk remedy, as placebo dressed in priestly language. After the residue analysis, they are reading them as pharmaceutical protocols. The Edwin Smith Papyrus, dated around 1600 BCE, goes further still. It contains 48 surgical case studies written in clinical language, wound classification systems, prognosis categories, treatable, uncertain, untreatable, step-by-step treatment procedures, contraindications. That is not mythology. That is structured, evidence-based medicine. The Egyptian word for physician is sadibunw. It appears in administrative records dating to 3000 BCE. These were not priests performing healing rituals. They were trained professionals with documented specializations: surgeons, dentists, ophthalmologists, and what we might today call pharmacologists. Brewmasters working in dedicated facilities, producing medicinal fermented preparations on an industrial scale under a system overseen by the House of Life, the ancient Egyptian institution that functioned as both a medical school and a research archive. So why did it take until 1980 for science to notice any of this? Here is the part that should make you genuinely pause. When Alexander Fleming identified penicillin in 1928, it changed medicine forever. The discovery was real. The impact was transformative. Hundreds of millions of lives were saved, but the story that came attached to it, the triumphalist narrative that humanity had lived in complete medical darkness until the 20th century, that ancient medicine was nothing but prayers and superstition, that the germ theory of disease was a modern invention with no ancient precursors. That story was never just science. It was also a form of historical arrogance, and the bones proved that story wrong. The tetracycline in those Nubian skeletons was not a curiosity. It was not an outlier. It was the chemical signature of a deliberate, generation-spanning, large-scale pharmaceutical system, one that operated across millennia, used infrastructure we can still excavate, followed protocols we can still read, and achieved outcomes we can still measure in the mineral structure of the people it treated. 3,000 years of pharmaceutical knowledge filed under mythology, dismissed by the civilization that replaced it. And by the time anyone thought to shine an ultraviolet light on the evidence, all that remained were bones and beer residue, quietly preserving the proof. Here is what I want you to take from this. Not just the facts about ancient Egypt, but what those facts reveal about knowledge itself. Every time a civilization collapsed, every time a library burned, every time a trade route broke down, every time a political system violently replaced the one before it, something was lost. Not just art, not just architecture, practical, biological, life-saving knowledge, the kind of knowledge that took centuries to accumulate and moments to destroy. The ancient Egyptians had physicians, brewmasters, scribes, and grain storers working together across hundreds of years to refine a process that genuinely fought infection and saved lives. They did not have microscopes. They could not see streptomyces under a lens. They had no concept of a molecule, but they watched outcomes. They recorded results. They built institutions around what worked. And today, as modern medicine confronts the growing crisis of antibiotic-resistant superbugs, infections that no longer respond to the drugs our entire healthcare system was built around, researchers are going back to ancient fermentation records, back to traditional grain preparation methods, back to biological processes that pharmaceutical pipelines never explored because they were never taken seriously. The next antibiotic breakthrough may not come from a laboratory computer generating novel molecular compounds. It may come from someone shining an ultraviolet light on bones that have been sitting in a museum storage box for 100 years. The Egyptians built their entire civilization around one belief: that observation, done carefully enough and recorded faithfully enough, can outlast any empire. Their breweries are rubble, their papyri are fragments, their cities are buried under sand, but the chemistry is still locked inside the bones, still glowing, which leaves me with one question for you. If a Bronze Age civilization could develop large-scale antibiotic production without microscopes, without germ theory, without a single chemistry textbook, using nothing but careful observation and a commitment to recording what worked, what else did they know that we have not yet found? Leave your answer in the comments below, because I read every single one.